Hello everyone, I am Sonali Mate and I welcome you all for the online sessions of Design of Machine Elements 2. Let's talk about unit number 2, that is Helical Gears. So in my this video I am going to talk about Introduction and Geometry of Helical Gears. So let's start with the Helical Gears. So basically two meshing gears may be mounted on parallel or intersecting shaft. So here as like spur gear, this helical gears can be mounted on parallel shaft or either they might be mounted on intersecting shaft. The teeth of the helical gears are cut at an angle which is called as helix angle. Now basically helix angle is defined as the angle between the axis of the shaft and the line of action on the tooth. Okay, so it is cut at an angle to the gear axis around 15 degree to 30 degree. Now basically the range of the helix angle of helical gear is 6, 8, 10, 12, 15, 20, 30. So 6 to 30 you can say. Now the larger the angle, smoother the motion and the high speed is achieved. So usually um, more than 15 the angle is preferred. So now basically helical gear pair. Now in that we know that there is one is pinion and one is gear. Now the main requirement is that both pinion and gear should not be of same hand. Okay, so their helical gear might be of right handed or they might be of left handed. So here you can see in the image, this is the spur gear in which the teeth are parallel to the axis of shaft. Whereas in case of helical gears, teeth are inclined at an helix angle to the axis of shaft. So the angle between these two is nothing but your helix angle, which is represented by sine. Okay, so here this image shows you the left-handed helical gear, whereas this image shows you the right-handed helical gear. Now the inclination of the thumb of the left hand represents the left-handed helical gear, whereas inclination of thumb of right hand shows the right hand helical gear. So, or basically you can say in case of left hand, teeth are sloping towards the left side, whereas in case of right hand, teeth are sloping down towards the right side. This how actually left hand helical gear and right hand helical gear can be differentiated or they can be identified. So basically, pinion and gear should be of different handed. They cannot be of same handed in order to transmit the power. So now there are two loads which are acting on the helical gear pair. One is thrust load and one is radial load. So basically here in the diagram you can see now this is the pinion and if suppose this is the gear. Okay, now this is for left hand driven gear pair. Sorry, right hand driven gear pair. Now in this case actually this is the pinion and this is the axis of shaft and here is the gear and this is the axis of shaft for the gear. Now here the thrust load, it acts parallel to the shaft of gears. It acts parallel to the shaft of gears. And now basically this thrust load is generated due to the helix angle. And talking about radial load, now this is the load which is perpendicular to the shaft. So this arrow represents the radial load which is perpendicular to the axis of shaft. Now the this radial load tends to separates this gear pair. Okay, but the amount of radial load compared to thrust load is very negligible. So designers or while designing we have to consider this thrust load factor severely. Okay, this is generated due to the pressure angle. Pressure angle is nothing but it is an angle between the line of action and the common tangent to the pitch circles. Okay, so this radial load can be seen in spur as well as in case of helical gear, but the amount of it as compared to other load is negligible, so we can neglect it. Okay, so now further helical gears are classified as parallel helical gears, crossed helical gears, herringbone gears. Okay, now in case of all the helical gears, uh, thrust load is obtained. So basically, we have to consider this thrust load while designing the any component or any machine or any gear pair. So let's talk about parallel helical gears. So here you can see in the image. So in this case, the axis of the pinion and the gear are parallel to each other. So it refers when the shafts are parallel to each other. Now the mating helical gears on the parallel shaft must have the same helix angle but of opposite hand. So this is the basic requirement that the helix angle is always constant or it should be constant always in case of parallel helical gears. Helix angle will be same for both pinion and gear, but the pinion and gear both should be of opposite hand. So next is crossed helical gears. Here in the image you can see that the axis of the shaft is not parallel to each other. They might be intersecting or they might be at particular angle. So the shafts are non-parallel. And the such type of gear pair is also called as skew gear. Now in this case, the hands of pinion or gear might be same. Okay, it might both might be left-handed or both might be right-handed. Now basically our discussion is focused on parallel helical gears. Next is herringbone gears. Now here in the image you can see it is nothing but the combination of two helical gears. Now such type of gear pair is used in order to reduce the effect of thrust load. Okay, so here you can see one is right-handed and one is left-handed. So to avoid the axial thrust, two helical gears of opposite hand. This is important. Two helical gears of opposite hand, they are mounted by side in order to cancel or in order to nullify the resultant thrust force. Because thrust force generated due to right hand and due to left hand will be in opposite direction, so they will nullify each other. Now herringbone gears are mostly used on heavy machineries and they are difficult to manufacture due to their complicated shapes. Okay, so let's talk about advantages of helical gears. Now here actually teeth are at a particular angle, so they engage more gradually than the spur gear. So you can say that as compared to spur gear, smooth and quiet operation is obtained. Helical gears are highly durable and are ideal for high load applications. They can be used for non-parallel and even for perpendicular shafts. So it does not have the limitation of parallel shafts. And also they can carry the higher loads. Next is at any given time, their load is distributed over several teeth, so it results in less wear. So load distribution is more uniform as compared to spur. Next is disadvantages. So one of the disadvantage of this is thrust force, which is generated. So we have to consider while designing it. So also there while designing we have to deal with the thrust bearings in order to reduce the effect of thrust load. Also there is a greater degree of sliding friction between the teeth and this produces the wear during operation, so proper lubrication system is needed in this case. The efficiency of helical gear is comparatively low. Why? Because mm, It is due to the contact between its teeth which produce the axial thrust and it generates heats. So this reduces the efficiency of it. And also, as the helix angles are there, so to generate the teeth at a particular angle, it requires more cost. Hence, the manufacturing cost of helical gear is also comparatively larger. So, talking about efficiency, here is the question for you all, that is efficiency of spur gear and helical gear. If they are compared, then these are the options. Efficiency of spur gear, whether it is equal to efficiency of helical gear or less than or greater than or none of the above. Okay, so the correct answer is efficiency of the spur gear is sorry, efficiency of the spur gear is greater than the efficiency of helical gear. So talking about the explanation of this, um, we know that spur gears teeth are parallel to the gear axis, whereas helical gear teeth are not parallel, they are at an helix angle. So due to this, actually there is a sliding contact between the teeth of helical gears. This sliding contact generates the more heat because the contact area is more, and as there is more heat there is a loss of energy, and this reduces the efficiency of helical gear, and hence you can say comparatively efficiency of helical gear is less than the spur gear. So one more question, that is for the same tooth size and equivalent width, helical gears can handle more load than the spur gear. Because so more load carrying capacity is there in case of helical gears. It is because the helical gears tooth is effectively larger since it is diagonally positioned, and larger the size of the tooth is, so larger area is in contact. So as the area of contact is more, so load carrying capacity is also more as compared to spur gear. So here is some comparison between helical and spur gear. So this what we have already discussed. Teeth are parallel to the axis where it is at an helix angle. Then contact between the meshing teeth occur the entire face width of the tooth. Here the contact between the meshing gear begins with a point of the leading edge and gradually it extends along the diagonal line. So here is a sudden contact and here is a gradual contact in case of helical gear. So sudden contact results in noise, whereas gradual contact gives some quieter operation, and load carrying capacity of helical gear is more, which we have discussed. Next is used for parallel shaft, used for crossed or any perpendicular shafts also. So spur gear it is limited up to less speeds, whereas helical gears are having high speed applications like automobile turbines. Here in case of spur gear only radial load can be seen, whereas in case of helical gear radial as well as axial thrust loads are seen. In case of spur gear contact ratio is low, and here the contact ratio is high. So up till now we have discussed about the introduction or the theoretical introduction of the helical gears. Now let's talk about the geometry of the helical gears. So here you can see there is a shaft on which the helical gear is mounted. So can you imagine which handed helical gear it is? So basically here you can see the inclination of the teeth of helical gear. It is towards the left side inclination, or you can call it as slope. It is towards the left side. So or also you can say that the inclination of this teeth can be represented by the left handed thumb. So this gear is nothing but left-handed helical gear. Okay, so now here is the angle shown, that is called as helix angle. So it is nothing but the angle between the line on the tooth and the shaft axis or center axis of the shaft. Okay, so this is called as helix angle, which is represented by psi. Okay, now here, if suppose we are cutting this helical gear in the through this plane, that is AA or section AA. So now this section AA is nothing but called as transverse plane, or which is also called as the plane of rotation of the helical gear. Here this how is the representation of the tooth, and the angle made by this tooth is nothing but your pressure angle, now which is also called as transverse pressure angle. And if suppose you are cutting this helical gear in the plane BB, that is the normal plane, and this plane is nothing but the plane perpendicular to the tooth element. Okay, plane perpendicular to the tooth element. So here the angle is called as normal pressure angle, which is represented by alpha suffix n, and here simply it is represented by alpha in case of transverse plane. Now next is Pn, P suffix n and P. P is nothing but the transverse circular pitch, whereas this Pn is nothing but the normal circular pitch. Now this Pn is measured along the normal plane, whereas P is measured along the transverse plane. It is nothing but the distance on the same points on the adjacent tooth, along the normal plane or along the transverse plane. PA is the axial pitch, where B is the face width of the helical gear. Okay, so this is what we have discussed actually, that is helix angle, what is P, what is Pn along the BP and AA plane now, what is axial pitch, face width. Now here you have to remember that the face width of the helical gear, it is usually made at least 20% longer than the axial pitch for the smooth transformation of the load. Okay, so face width is always greater than the axial pitch. Axial pitch is nothing but the distance between corresponding points on adjacent teeth measured along the plane parallel to the shaft axis. Plane parallel to the shaft axis. Okay, so here now from the diagram you can see actually. So how was the diagram? This was the transverse circular pitch, and this is nothing but the normal circular pitch, and the angle between these two is your psi. So this is P and this is P N. So from the diagram you can say this how actually it was. So from the diagram you can say cos psi is nothing but Pn by P. So Pn, that is normal circular pitch, can be written as P cos psi. Now we know that the diametral pitch of the spur gear, it is given by capital P, and it is given by the formula, that is number of teeth upon pitch circle diameter, that is d dash. So capital P is Z by d dash, and circular pitch it is given by pi d dash upon number of teeth. So the pi d is nothing but your circumference. So the relation between these two can be written as capital P into small p is equals to pi. So this is the relation. So same relation will be going to apply for helical gear. So for normal and transverse diametral pitch. So for finding normal and transverse diametral pitch. So that is now here in case of spur gear, this is the relation which which can be written for helical gear, that is Pn is equals to pi. So now we know that Pn is equals to P cos psi. So substituting the value of small pn and small p. So small pn is pi by capital Pn, whereas whereas small p is given by pi by capital P. So pi get cancelled out, and what remains is Pn is equals to P cos of psi. Now, to write down in terms of module, now we know that the diametral pitch are reciprocals of the module. So, or you can say P is nothing but 1 by M. So similarly, Pn can be written as 1 by Mn. This is your transverse diametral pitch, and Pn will be normal diametral pitch. Okay, so this capital Pn can be written as 1 upon Mn equals to, now this P can be written as 1 by M, and this cos psi as it is. So the relation you get is Mn is equals to M cos psi. Now this is nothing but the relation between the module in two planes, that is normal and transverse. Now what is module of the gear actually? It is defined as the inverse of diametral pitch, as I have told you. Now M formula is, here you can see in the image, this represents, just a minute, this represents the diameter of the gear, and this represents the number of teeth. So module is nothing but the diameter upon number of teeth. Now for the same diameter, you can see as the module increases, the number of teeth will go on decreasing. So there is an inverse relation between module and number of teeth for the constant diameter. If your module is 2, you can see there are several number of teeth, and if your module is 5, only 3 number of teeth you can see for the same diameter. So module and diameter is having direct relation, whereas it is here module and number of teeth will have inverse relation. Now next, talking about axial pitch. So from the diagram you can see that tan psi can be given by P by PA. So PA can be written as P by tan psi. The relation between the normal pressure angle alpha n in the normal plane and the transverse pressure angle is given by the uh, formula, that is cos psi is equals to tan alpha n upon tan alpha. Now further, now we have to find the formula of D. So further, now we know that P, that is pitch circle diameter of helical, sorry, P, that is a circular pitch, which is given by pi d by z, where d is the pitch circle diameter of helical gear and z is the number of teeth. So pi d by z. So d can be written as zp by zp by pi. So this pi upon p can be written as capital P, that is nothing but your diametral pitch. Okay, so z by p. Now diametral pitch is inverse to the module, so it can be written as z m. Now this m can be substituted in terms of mn, that is, we know the relation, that is mn is equals to m cos psi. So zmn upon cos psi. So simply d is equals to zmn by cos psi. This is the formula for the pitch circle diameter of helical gear. Now further, this is the formula of center distance between the mating gears. Okay. Now center distance, basically it is given by the formula, that is d1 by 2 plus d2 by 2, where d1 is nothing but the uh, pitch circle diameter of pinion, and where d2 is nothing but the pitch circle diameter of gear, or you can also call it as for first helical gear and for second helical gear somehow. Okay, so here now we have to substitute the value of d, which is in terms of normal module, that is z mn by cos psi, and this 2 as it is. Similarly here z mn upon 2 cos psi, so z1 and z2 over here. Now taking common, that is mn module is taken as common, so this formula becomes z1 plus z2 upon 2 of cos psi. So in this video we have talked about the geometry and the introduction of the helical gears. I hope you have understood. If you are having any doubt, you can write in comment section. Thank you.